So it's really understanding the magnitude here. When we get into nutritional ketosis, we consider that an optimal range of ketosis. And when you stay in that range for several weeks and months, the body fundamentally goes through adaptations to maintain near perfect inter-organ fuel exchange. But we know fundamentally what happens when you're keto-adapted is you become very proficient at burning fat. Your rates of fat oxidation double. And that's true if you're a type 2 diabetic or if you're an elite ultra-endurance athlete, you will essentially double your rate of fat burning. So again, we knew all that. We knew most of all that for decades. What's newer in the science of ketosis over the last 6-7 years is the understanding now that betahydroxybutyrate in particular is a potent signaling molecule. We worked out a lot of the mechanisms here. For one, it's a potent histone deacetylase inhibitor that is a primary way in which we upregulate expression of genes. It also inhibits other pathways in cells that are related to inflammation and oxidative stress. There were actually 2 separate groups working independently on longevity experiments that started about 3 years ago, and both published their results simultaneously in Cell Metabolism about 6 months ago. And interestingly, both studies found more or less the same thing, that mice fed ketogenic diets not only lived longer, but had an expanded health span. So they lived healthy longer. They functioned physically better and cognitively had higher levels of neurocognitive performance than mice not in ketosis. And they worked out a lot of the mechanisms, and it turns out, in terms of anti-aging anyway, a lot of the same underlying mechanisms that we've uncovered with caloric restriction are mimicked by ketones and ketogenic diets without the caloric restriction.